people, aliens, and all extraterrestrial life. My name is HH24 and today we'll be exploring Titan, Saturn's largest moon, which is even bigger than Mercury. It's located around 800 million miles from Earth, which makes it much harder to reach than our own moon. But before we dive into the challenges of landing on Titan, let's talk about hypersonics. Hypersonic speeds, which are 5 times the speed of sound, are the key to fast and efficient space travel. They let us cover vast distances very quickly, which helps us land on moons and planets far away, such as Titan. Now let's go to Titan and see what challenges await us. Problem number 1. The first problem we're going to face is the temperature. The temperature on Titan can get as cold as negative 290 degrees Fahrenheit or negative 179 degrees Celsius, which if you don't know is very cold. This means that our aircraft will need some advanced thermal insulation, something that can withstand the super cold temperatures but also maintain structural integrity. We can use materials like aerogel or vacuum insulated panels to create a multi-layered thermal insulation system. Along with the extreme cold, we'll also be facing something on the other end of the spectrum, such as extreme heat, as hypersonic travels can generate extreme heat during atmospheric re-entry. And in order for the internal components of our spacecraft to work properly, we need a good balance of cooling and insulation. Adding heat-resistant materials such as reinforced carbon-carbon, also known as RCC, for heat shields and a liquid cooling system will ensure that the spacecraft maintains its safety during these temperature extremes. Now that we are safe in the extreme cold and the extreme heat, let's move on to problem number 2. Problem number 2, the atmospheric pressure. Titan's atmosphere is much thicker than Earth's and is made up of mostly nitrogen, with surface pressure being 1.5 times stronger than that on Earth's sea level. This extra force means that the spacecraft must be built using materials that are lightweight but also durable, something like titanium alloys and composite polymers that can avoid breaking and remain functional. More specifically, as our spacecraft enters Titan's thick atmosphere at hypersonic speeds, it's going to generate powerful shock waves and experience intense drag. This drag will abruptly slow down the spacecraft, putting immense pressure on its structure and components. To manage this issue, adaptive control surfaces such as adjustable wings would help stabilize and guide the aircraft during descent. This will prevent the spacecraft from spinning or sustaining any major damages. Furthermore, a durable parachute system using strong materials like Kevlar would help safely slow down the spacecraft. Lastly, specialized shock absorbers such as crushable aluminum honeycomb structures will help absorb all the energy from the landing. This will ensure that the spacecraft and all its internal components remain safe and protected during the landing. Problem number 3, the radiation exposure. While this problem may seem similar to the previous problem, it surely comes with its own unique set of challenges. Because while Titan's thick atmosphere can provide some shielding, the high-energy cosmic rays and solar radiation still pose a major risk to the spacecraft and its internal components. Since over time, these radiations can degrade electronics, damage sensitive systems, and pose a hazard to any human passengers or biological experiments. To counter this, the spacecraft will need specialized radiation shielding, such as layers of polyethylene, which is lightweight and effective against cosmic rays. Additionally, the electronics can be radiation hardened to ensure reliable functionality during the trip's duration. However, we can't forget about hypersonic speeds, as they also create risk during atmospheric re-entry. They induce electrical charge buildup on the spacecraft's surface, which can potentially interfere with onboard systems. However, since every problem has its solution, advanced grounding and shielding techniques can prevent such disturbances. So, overall, combining all of these strategies together will ensure that the spacecraft and all of its instruments stay intact and operational during the trip's duration. We finally landed on Titan. Now go have some fun, stay safe, and this is HH24 signing out.